EF lenses were born in 1987. From the start, they were innovative, cutting-edge lenses for 35mm SLR, incorporating breakthrough technologies like a fully electronic mount system, built-in micromotor, and electromagnetic diaphragm. Since then, their spirit of innovation has remained unchanged, but their performance has continuously advanced through technologies such as 3D CAD and the skills of Takumi masters. These optical technologies, accumulated through the development of lenses, are applied to wide-ranging Canon products. In 2014, our long pursuit of advanced technologies led to the production of the 100 millionth EF lens, a world record for production of lenses for interchangeable lens cameras. Through technological innovation, EF lenses continue to evolve and produce the highest image quality. From wide-ranging optical technologies and quick, accurate drive mechanisms to sophisticated coatings and leading-edge R&D, Canon pursues the creation of the perfect lens.
シャープでディストーションのない大口径レンズを設計するためには、極めて高精度な大型の非球面レンズが必要です。ガラスモールド非球面レンズを超える大口径で高精度な非球面レンズ、それが検索非球面レンズです。キヤノンでは1971年に検索非球面レンズを開発し、その製造技術は今でも進化しています。
Aspherical lenses minimize aberrations. For example, they significantly reduce spherical aberrations in large diameter lenses and lower distortion in wide-angle lenses. They also reduce overall lens size by requiring fewer elements, which enables more flexible lens design. Canon's quest for ever more advanced aspherical lens technology continues. It has long been known that natural fluorite offers properties appropriate for camera lenses, such as an extremely low refractive index, which suppresses light dispersion, and excellent transparency in the infrared and ultraviolet spectrum. However, the size and impurity of natural fluorite prevented its adoption. Fortunately, Canon challenged the impossible and succeeded in making the practical use of fluorite a reality.
キヤノンは1969年にホタル石レンズを開発しました。ホタル石はガラスではありません。フッ化カルシウムを原料にした人工結晶を高精度に研磨して作ります。
Fluorite lenses offer better dispersion properties than regular glass. This helped produce lenses with optimal correction of chromatic aberration. Two fluorite lens elements are featured in Canon's most recently developed 400mm super telephoto lens, enabling higher resolution shooting and lower weight than in the previous model. Canon continues its efforts to produce super telephoto lenses with sharp, high-contrast images, a lightweight body, and highly practical performance. Light slightly bends as it passes around the edges of objects, a phenomenon called diffraction. In 2001, Canon's multi-layer diffractive optical element became the world's first lens element for cameras to employ diffraction to control the path of light through a lens. This DO lens features a spherical glass lens element with a unique resin diffraction lattice, only a few micrometers thick, produced through high-precision technology. This single element replaces 2 or 3 conventional lens elements, while successfully reducing lens size and correcting chromatic aberration. the lens caused a ring-shaped flare to appear whenever shooting directly into the light. To resolve the issue, Canon developed a close-contact, dual-layered diffractive optical element in 2014. This element combines with a new lattice material to eliminate the layer of air and minimize lens flare. The recently developed EF 400mm f4 DO-IS2 USM lens also places the optical elements deeper in the lens to cut off unnecessary light and further minimize lens flare. Canon's development of DO lens technology continues. Autofocus is an excellent tool for accurately keeping your subject sharp. For this reason, Canon develops its own unique drive systems. These include the advanced USM ultrasonic motor.
高速で高精度の AF には超音波モーター USM が必要です。キヤノンでは1987年に世界で初めてカメラ用交換レンズに超音波モーターを実用化しました。USM はトルクが高く、作動音が静かで制御性に極めて優れたモーターなのです。
USM converts ultrasonic vibration to rotational energy with 1,000th of a millimeter precision. To achieve faster, smoother, and more accurate autofocus, Canon continues the development of this unique technology. The STM stepping motor built into EF lenses was launched in 2012 and was developed to enable smoother, quieter autofocus for movie shooting as well as still images. For example, the lead screw type is ideal for movie shooting, while a gear type helps minimize size. The lead screw type STM's simple structure contributes to smoother, quieter operation. And the lead screw type STM activates in sync with pulsed power to enable quick response when starting and stopping, as well as excellent control. STM is featured on many lenses. Canon is devoted to improving the shooting experience for movies as well as still images. Camera shake commonly occurs during shutter release. To tackle this problem, Canon developed a lens-based image stabilization system that can be optimized for each lens, rather than a body-based system that is the same for each lens. The IS, Image Stabilizer, introduced in 1995.
望遠レンズでも手ぶれのない撮影を実現するために1995年に私たちが開発したのがイメージスタビライザー IS です。振動ジャイロで揺れを検知し、一部のレンズユニットを同ブレを打ち消す方向に平行移動させます。流し撮りへの対応やマクロ撮影に有効なハイブリッド IS の開発など IS の技術は今も進化しています。
The IS is refined to match the characteristics of each individual lens so that focusing is accurate and the viewfinder view is stable. High-level camera shake correction is achieved even when shooting with a telephoto lens. This IS technology expands shooting freedom, making it easier to capture the moment anytime, anywhere. One of the biggest obstacles to overcome that determines the quality of the shot image is flare and ghosting. This optical phenomenon is caused by light reflecting off the lens or sensor and appearing on the image. In backlit or strongly lit situations, it makes part of the image appear white. But Canon is striving to eliminate it with cutting-edge coating technology.
逆光でもコントラストの高いクリアな映像を得るために 2008年、キャノンは全く新しい方式の反射防止コーティング SWC を開発しました。
SWC technology minimizes reflections by using wedge-shaped nanostructures shorter than the wavelength of visible light to blur the boundary between materials with different properties such as air and glass. By combining SWC with super spectra coating technology, Canon significantly reduced the reflection of light. Canon will continue to pursue solutions that realize ever clearer images without ghosting or flare. The technological advancement of EF lenses continues, so users can capture beautiful images and movies as they appear in real life without missing a moment. We will continue to develop EF lenses with higher resolution, higher image quality, and more faithful reproduction capabilities.
Canon